Alrighty, we're on the video here for like terms and combining like terms. And the first thing we have to do when we do this is understand the meaning of some vocabulary. So we have the word term. All it is, it's a part of an algebraic expression separated by an addition or subtraction sign. So you can see this is my addition sign. This 3 right here would be its own term, okay? As would 2n, 4n, and the number 5. All right, those are 4 terms. So this problem contains 4 terms total. A constant is a term that does not contain a variable. It's a number. So this 3 right here would be a term. This 5 right here would be a term. So the 3 or 5 would be a constant. A coefficient, it's a fancy term for a factor of a term that contains a variable. So in front of this n, there's the number 2. In front of this n, there's the number 4. The 2 and 4 are considered coefficients here. And then finally, like terms, terms that contain the same variable. So this right here, 2n, would be a like term with the 4n. And you could rewrite this to say 3 plus 6n minus 5. So let's look at some examples here. So if we were to combine this and simplify this and make this into like terms, all we would do, this right here, if you don't see a coefficient with it, it's because it's 1x. So they don't, in the book, they don't usually use the number 1. In the book or real life in general, they don't use the number 1 there. They just write x. So 1x plus 4x plus 6x, that's going to equal 11 times x. And you say, well, how does that work? Imagine if we use analogous numbers and we use the number 3 for x. So we have 3 here. We'd have 4 times 3 here, which can be written really as 12. And if we had, that's a bad 12. Let's rewrite that, 12. And then we had 6 times 3 right here. That's really 18. So if I add these, I get 3 plus 12 plus 18. Well, that equals 33. And you can do that out if you need to, but it would equal 33. And if I substitute for x right here, I would substitute a 3, and we get the same thing, 33. So that's how that kind of works. So here's another example. This one has 2 variables. All we're going to do is distribute the 7. So 7 would be multiplied times 3x, and that equals 21 groups of x, 21 times x, and it would also be distributed over here to the 5y. So we're going to add 35y. One more example we're going to try is, we've got a word problem here. And it says 8 friends went to a hockey game. That's important to know, that 8 part. So we're gonna have to highlight that, I think. So 8 friends. There's 8 people involved. The price of admission per person was X dollars. So that's admission. X dollars. 4 of the friends, so 4 out of 8 people, paid an extra $6 for a player guidebook. That means 4 players didn't. Write and simplify an expression that represents the total cost. So it looks like X dollars, we could say, since 4 of the friends paid for the guidebooks, we would say 4 times X dollars plus 6. And where I got this from, the X is for the admission. 4 friends paid for admission, and they also paid a certain amount, $6. Put the dollar symbol there. And this is also dollars. That's a bad dollar symbol, but you get the idea. And we're also going to add on to this the 4 friends that didn't pay for an admission book. So they paid X. And so what we end up with here is 4X plus 4 times 6. We have to distribute the 4. Plus 4 times X. And the 4 X's, we can combine those and make those 8 times X. And then the 4 times 6 we can call 24. So really what we did here is we have 8 people getting admission, and we don't know what the admission cost is, plus $24 worth of player guidebooks.